Welcome to our Machinations 101 session. Today we're going to be going through right the way from the very basics of Machinations. We're going to be going through each of the different objects and showing you how they work. We're going to go through the different play modes. Hopefully we're going to show you how to get familiar with the chart and how to use it in your processes. Learn some tips and tricks along the way of how to keep your models nice and tidy. And throughout today's session, give you the opportunity to ask us any questions you have as we go through today's session. My name's Matthew, I'm the evangelist for Machinations. Been in the industry for quite a while, and alongside me today, as always, freshly shaven, especially for today's event, is Cesar, our diagram architect. You can see what his beautiful beard used to look like, but say hello, Cesar.
Hello, Matthew. As always, it's an absolute pleasure to co-host this with you.
Good. Hopefully we're going to have some fun. At the end of today's session, we're going to be opening up the microphone and opening up the floor to anyone that wants to come and ask us questions and talk about either the content we've been through today or just game design in general, or any industry trends or anything you want to chat about, really. And then throughout today's session, we're going to be checking to make sure that what we're sharing with you is making sense, and we're going to be doing this via polls. And I'm going to launch one right now just to find out how much people are familiar with Machinations so far. And I'm going to do this. I'm going to seamlessly transition from between my screens while we do that poll. So the options we've got there are not started yet, just some doodles, a few mechanics and subsystems, full meta, or everything in there. So drop your answers into the poll. I'll give you another 2 seconds, then I'll end the poll. 1, 2, 3. And here come the results. So perfect. We've got a great one. We've got one person who's an expert already. That's brilliant. Might pick up something new, but we might come to you to ask you for some help. Lots of people not started yet, and lots of people just doing some doodles. This is the ideal session for you. We're going to really be going right the way from the very basics, walking through every object. So before we get into the objects, I'm just going to go through a quick demonstration of how to actually get objects onto the canvas, because there's a few options and they're not always immediately obvious. So the first one is dragging our objects and dropping them onto the canvas from the left-hand side. We can carry on doing this as much as we like. You'll notice I'm using the grid lines and I'm using the guides. What these mean, I'm super pedantic and I really want my objects all neatly lined up. So I'll position these, and you'll notice that when they're lined up with other objects on the canvas, you see these blue lines to make sure that you've got everything aligned properly. Now, if I went a bit wrong and started having objects out of alignment, let's chuck a couple in here, slightly broken to trigger my OCD. One of the ways that you can do is, once you've connected these up as you need to, if you highlight these, you can see on the right-hand side, we've got a few alignment options. So if I hit that one, it's going to bring them all into a nice straight line for me so that I know they're all in the right place. While the grid lines are on, you'll notice that everything kind of snaps to a position. With the grid lines off, we have full granular control of exactly where we place them. So it's really up to you of how granular you want to be with your control. In fact, I'm going to leave my grid off for now. The other thing that we can do is obviously highlighting multiple ones simultaneously. The other option is to, as a quick shortcut, is if we double click an object. So I'll stick a source down here. If I double click a pool, it's going to then put that pool to the right of the object I had highlighted, so where it's got this blue circle around it. And we can carry on adding objects just by double clicking them on this left-hand side panel. If I want to go in a downward direction, if I hold the control key and double click, it's going to go down. If I then want to go to the left, I can hold shift and control. And if I want to go up, if I just hold the left shift, that will go in an upward direction. If I want to add an object with a state connection instead, if I hold the Alt key, it's going to add it with that state connection. So these are some great shortcuts that really help us quickly start adding in plenty of objects into our canvas. But now we've got them on there, let's talk about what these objects are and how they operate. And what I'm going to do is I'm going to be walking down this left-hand side control panel. I'm going to be going through each of the different objects and explaining how they operate and how each of their properties operate. So the very first one at the top here is source. And a source is where we get our resources from. So it's an infinite resource pool, if you like, where we can create resources and bring them onto our canvas. Now on the right hand side, in fact, I'm going to make that a little bit bigger. On the right hand side, we've got all the properties of our sources. And you see we've got these 4 trigger states, and I'm going to explain what each of these mean as we go through. I'll hit play, and you'll notice this first one is passive. So it's just a plain triangle. This means that it's waiting there passively for something else to trigger it. Don't worry if you don't know what triggers are, we're going to talk about them a lot. This next one, it's got the little mouse icon on here. This means it's interactive. Therefore, to carry out its task, we have to click on it while the simulation's running for it to play its task or trigger. So in this case, it's generating 1 resource and it's firing it over into this pool. Next up, we have automatic. And what an automatic object will do, it will carry out its task each step of the simulation. So in this case, it's generating 1 resource each step. At the bottom here, we have on enable. This used to be called on start, but we've updated it to now be called on enable. And what this means is when we first hit play for our simulation and the simulation starts, the on enable objects will carry out their task during the very first step of the simulation. This means that they're only going to do that once unless we then trigger them in another way. So once they've carried out their task, they then become passive, just like this first one. Now, Cesar, what are you going to use your sources for in your models?
Yes, sources are basically, you can think of them as an infinite generator of resources. So whenever you have any sort of resource that you can think of player health, think of player, I don't know, currency. So say you have a racing game and your player wins the race, you're going to use a source to generate the currency that the player will receive for winning that race, right? Think of your player healing. You're going to use a source to create health that will be stored in a pool for your player. So basically, whenever you are thinking of generating new resources, instead of converting them from other resources, you're going to use a source to create them.
Perfect. Thank you, Cesar. Up next, we're going to talk about drains. So now that we've created some resources onto our canvas, we want to think about what we can do to remove them from our canvas next. Here, you'll see we've got these same 4 trigger states. So when I hit play, my passive one's just going to wait there to be triggered by something else. My interactive one, I'm going to click on this and it's going to drain one of the resources from the pool. Our automatic one's almost finished. It's draining those each step. And I'll hit play again and see our on enable. It's just carrying out its task on the very first step, then it's waiting for the next, for something else to trigger it. As well as having our trigger states, we also have this action option on drains, which is pull any and pull all. What pull all means is that it'll wait until all of the resources are available until it will carry out its action. So here we've got a 5 on this resource connection. So it's going to wait until there's 5 resources available, and then it's going to drain those 5 resources. So I'll show you this on the interactive version. So here, once there's 5, I can trigger this manually, it'll drain those away. If I try to do it before there's 5, it's just going to flash this orange and say it's not available. But once there are 5, it'll drain them. Here with our automatic ones, you can see the difference that this makes. So this drain is set to pull any, this one's set to pull all, this one's waiting till there's 5 available before draining them. This one's, because we've got it set to pull any, it means it will pull up to 5 rather than waiting until there's 5 resources available. So Cesar, how are you going to use your drains in your models?
Yeah, so basically drains are the exact opposite of sources, right? If sources are used to create resources, drains are used to destroy them. This is useful when you want to get rid of resources out of your system. So going back to the health example, using a source to feed your player health, you would use a drain when the player loses health. Think of an item that has durability, for instance. You would destroy the durability of that item, so you would keep track of it and you would drain it constantly until it reaches 0. So anytime you destroy any type of resource, you're going to be using a drain to remove it from your system.
Perfect, thanks. Up next, we're gonna look at pools. But before I do that, I'm just going to ask another quick poll of the audience, just to find out what sort of games people are working on. So I'm going to launch a quick poll. We've got 4 options there: premium games, free-to-play games, Web3 games, or just starting out in your game design career and wanting to learn Machinations. So love you to just drop your answers into that poll, just so we can see what type it is.
We have a question in the Q&A while we wait for the answer, which is, how do you make the drain touch with an ampersand? I think it's okay.
So in fact, we've got one here. So here we've got that ampersand means that it's has the pull all action type, and the interactive means, so we've got interactive pull all. So when I do this, if I try and trigger this before there's 5 in there, it'll just flash because it's not available. Once there's 5, then I can drain those 5 all in one go. Perfect. Where's my poll gone? And then the poll, I'll share the results with everybody. So we've got quite an even mix actually of people that are in today's session. 23% in premium games, 19% free to play, 20% in Web3, and 38% just here to learn Machinations, starting out their game design careers. Fantastic. So let's talk about pools next. Now, we've kind of already seen pools a couple of times where I've been using them. Pools are where we store resources once we've added them to our canvas. So again, we've got 4 different activation states available. So passive, interactive, automatic, and on enable. You'll notice that the sources here are all passive, so they're not triggering themselves, and the pool is actually triggering them to carry out their action. So this first one, once I have passive and passive, this is going to give me an error message to say pool missing resources, active input resource connections, or active input node modifiers. So this means there's nothing there to actually make these objects carry out their action. Here I have my interactive one. So when I click this, it's going to pull one resource from the source into the pool. My automatic one's carrying out its action each step. And my on enable, I'll hit play again. This will only carry out its action, which is to pull one resource in the first step. Now, one of the things I got caught out with the very first time I started using Machinations is looking out for a double automatic condition. So here we've got a resource connection with 1 on it, but we have an automatic source and an automatic pull any pool. When I hit play, you'll see that 2 resources are coming across this connection each step. This is because, as well as the source pushing one resource out, the pool is effectively pulling one resource as well. So it doubles up the number of resources that are going between those connections. So important to look out for that one. I know I've been caught out by it a number of times. Up next, as well as pull any, the other option we have in our action is push any. Now I've set this up deliberately to fail. There's nowhere for these resources to push any resources because they're only have inbound resource connections. So let's try that again with another push any configuration. So here I've got 10 resources. When I click this pool to carry out its action, it's pushing one resource into the next pool. Here are automatic ones pushing this each time. Here are on enable pool, although it has 10 resources in it, because there weren't any resources in it the very first step, it means it's not able to push those forward. So it's really important to think about timing and the impact of the steps with Machinations, that the first step, resources are going to be sent from the source to the pool. the next step, the resources will go from this pool to the next one. As well as push any, we also have pull all. So just like we have with drains, we have this pull all mechanic configured in here. So I've got my actions. This one's pull all. So once there's 5 resources available, we can pull them. But if I try and trigger this before there's 5, it's failing to do so. Once there are 5, they're all there. And again, just like with drains, if we have pull any rather than pull all, this means it'll pull up to 5 rather than waiting until there's 5. Up next, pulls, because they have both this pull and pull option to them. They have push all, which is then pretty much the same as pull all, but here it's in the middle object rather than the end one. So if I try and push all, it's not going to work until there's 5. Once there's 5, it'll send them through. A couple of other things that we can do to configure our pulls. The first one is over here. We've got a couple of extra options. The first one is display. So here, when I hit play, we've got 5 resources coming in. These will be shown as the counters up until there's 25 resources in there. Once we go over 25, it'll then show the number. The reason for this is we set the display character here to be -1. This means anything larger than -1, it'll show the number rather than the actual resources. If I were to set this at 0 and hit play, you'll notice it just stays blank until it starts to receive resources. I often quite like to see the number in there, see the 0 in there while I'm waiting, so I'll leave that at -1. We then have our capacity. So with our capacity on these resources, I've set them as 4. The default would be -1. So -1 effectively means infinite capacity. With 4, we then have 2 different overflow characteristics. The first one is block. So once this pool reaches 4 resources, it's not going to allow any more resources to come into it. The second one is then set to drain. I'll hit play on that again. Once it reaches 4 resources in here, it will still carry out its action and pull a resource into it, but it's then going to drain it from our canvas, effectively destroying that resource because there's no more space available. As well as that double automatic state I was talking about earlier that doubled up resources, it's important with pulls to think about your push and your pull configuration. Here I've got a automatic pull any pull. I also have an automatic push any pull, but this means there's nothing to actually move the resources between these 2 pulls. The one on the left is pulling, the one on the right is pushing. So Cesar, you've come up with a quick test for us to see whether or not people are following along with us at the moment. So do you want to talk us through what we've got here?
Yes, we are using the 3 nodes that Matthew has spoken about so far. We have our source, we have our pool, we have our drain. What we're going to do is we are going to run this model for 3 steps, right? Each of the nodes, so aside from the pool, the source and the drain are both automatic, so they're going to carry out their actions in every step. And at the end of 3 steps, the question is how many resources will we have in our pool?
Perfect. And I'm going to launch the poll. So have a quick think about it. Count it up on your fingers and your toes if you need to. How many resources you think will be in this middle pool after 3 steps? Great. Lots of right answers coming in. I'll give you a few more seconds and then we'll play the simulation for 3 steps and show you what happens. Perfect. I'll end the poll there. So step 1, we have 4 resources come in. We didn't drain any at that point because the resources hadn't reached that end drain. Step number 2, we lost 2 resources, but we gained 4. Step number 3, we lost another 2 resources and we gained 4. So the correct answer there was 8. Pleased to say 73% of you got that one right. A couple of you didn't quite get there. Don't worry. Practice makes perfect. Up next, we're going to talk about gates. Oh, actually, sorry, Cesar, how would you use pools in your simulations? What are you normally using them for?
Yeah, so whatever type of model you're building, I guarantee you that your most used node is going to be the pool. So you're going to need pool to basically store every type of resource that you have in your model. So going back to player health, right? Because it's a classic example. We were talking about how to generate or lose player health, but that player health would always be stored in a pool, right? You can store the ammo that you have, for instance, for a weapon. You can store the durability of an item. You can store even the ownership of an item, right? Say you want to check that you have a certain gun. You would use a pool to store the fact that you have that gun and use that further. So whatever type of resource you need stored and further used, you will use a pool node.
Fantastic. Thank you, Cesar. Up next, we're going to talk about gates. And I should mention, actually, so this model that I'm walking through today, which has got all of these configurations in, we will be sharing this out with everybody. It's in our templates. I made this, and I still occasionally come back to it to check something and refer to it if I need to. There's a question up in the Q&A. Can you change the amount of time the resources are transferred? Like, for example, a simulation of a gun firing rapid fire to a slow one, bot running at the same time. Yeah, actually, we're going to come on to some of that a little bit later on. So I'm going to hold your question for now, and we'll circle back to it. So up next, we're just going to talk about gates. So gates are a way of moving resources between different objects. Here's our interactive one. This gate's going to pull one resource all the way through in one step from the source to the pool. You can see our automatic one firing constantly. The reason for this is that gates are intermediate objects. This means they carry out their task during a step. So here we've got 4 gates, and one resource is going through those 4 gates at the same amount of time or same number of steps taken to go directly from a source to a pool. Now, the way in which we normally use these are where we've got multiple paths to connect from our for our resources. So here I'm using an automatic gate. So this is pulling a resource from the source and it's depositing it into one of these 2 pools. We have 2 options. We have deterministic and random. When it's deterministic, it's going to distribute these resources between these 2 pools on a regular basis. Sorry, a consistent ratio. So an equal number between the 2. Here we have a random gate. This means it's randomizing where this resource is going to go to. So this is the first time we've kind of seen Monte Carlo simulations in action. And the way to think about Monte Carlo is if you were to flip 10 coins in a row, statistically, you'll have 5 heads or 5 tails. Now, in reality, you very rarely get exactly 5 heads and 5 tails. When you do that, you get a whole range of different results. And that's what Monte Carlo's doing. So here, within a few seconds, we can then start to see that this pool's got slightly more resources in it. That time, in the next simulation, it could be different. So effectively, Machinations is using Monte Carlo to flip a dice for each resource that comes through and determine where it should go. As well as being able to use whole numbers, we can also use percentages. So here I've got 50% on each of these. It's a deterministic one, so it's going to deposit exactly 50% into each of these. This next one, I'm using a random gate with 50% on each one. It's really important to note you can't mix percentages and whole numbers. So when I hit play, this whole configuration's been grayed out, and it's going to explain why it's grayed out. Here is an example where we've got less than 100%. So when it's deterministic, 50% of the resources that come through this gate are actually drained by the gate. And then the remaining 50% are split between these 2 pools. If we go over 100%, Machinations will treat these as ratios. And this is particularly important if we're using conditions on these connections so that we're turning them on and off, but we still don't want to lose any resources. Just as we've seen with pools and drains, gates also have this pull any configuration. So here it's going to wait until there's 5 resources available, and it's going to pull all 5 through and distribute them according to the gate. It's worth noting, so here we've got a prime number, so it's going to split it 3 and 2. Between each step, a deterministic gate will remember how the resources have been distributed. So this means that 50% of our resources still end up in these 2, and you'll notice that every other step it's flipping which pool is receiving 3 and which one's receiving 2. With a random gate, it's effectively rolling a dice for each resource that comes through here. So you'll notice that it doesn't matter. At some points, if we ran this long enough, at some points, all 5 resources would go into one pool and none into the other, and a whole range of different results. The last usage we have for a gate is as a way of triggering other objects. Here, I've got a gate configured with 2 state connections, both 25% on the labels. This means that we have a 25% chance of triggering one of these passive sources. So you can see they're gradually distributing the resources. Here, we're doing the same thing, but with a random gate. So there's a 25% chance that one of these sources is going to be triggered. Cesar, I think you've got another puzzle for us.
Yeah, I do. I want to first touch on 2 questions in the Q&A. Sure. First one being, does Machinations support fractions? Let's say I want to push or pull 0.5 of resource. Is that supported? It is not currently supported. It is in our roadmap. The way we handle it right now, let's say you want to do dollars and cents, is we convert everything to cents. So in your case, doing 0.5 of a resource, you multiply that by 10, you move 5 resources, and then if you want to do math, you can convert it back or not. So that's the way it's currently done. But resources, you can have fractional numbers inside the register. We'll talk about those later. But as the dots that you see moving and resources, they can only be integer numbers. And the second question, so for example, let's say when a player has a certain capacity of health, would it be a part of a pool? Would the pools work like it is taking health and pushing would be acquiring it? So if you want to have a player health with a capacity, let's say of 100, you're going to simply have a pool node, right? It's going to have the capacity property set to 100. And on acquiring health, it depends because there's multiple ways to approach that depending on how you want to implement it. So for instance, if you have the case where if you start a new level, for instance, you go back to full health, right? You're going to use a source there because basically you generate that health out of nothing. If you have a system where if you drink a potion, let's say, that potion restores 50 health. In that case, you're going to use a converter, which we'll touch upon shortly, because basically you're taking one resource from the potion pool and converting it into 50 resources of the health pool, right? So it's situational, but you would use other nodes to create resources from your pool, and you would use your pool to store the health with a capacity of 100 to ensure you never go above 100. Nice. Which Matthew is doodling really fast. Yeah. So, and back to the exercise at hand, which you just spoiled, by the way.
Oh, no, I did too fast. No one saw.
Yeah, no, I hope no one saw. So we have our source. Again, no trickery here. We have a source. We have the gates, which we just discussed about. We have a pool and a drain. We're not interested in the drain. You can see how the gate, which is deterministic, splits the resources that it receives, right? And we are interested in how many resources will a pool have after 3 steps. All of our questions will be after 3 steps, so better get used to it.
Perfect. I've launched the poll. So is it 6, 12, or 30 resources that will end up in this pool on the right-hand side after 3 steps? I hope I didn't spoil it for anybody.
I wasn't paying attention, as I just noticed after like 15 steps.
Perfect. I'll give you 2 more seconds. 3, 2, 1. I'm going to close the poll. So let's have a look, see how we did. Step one, so we fire in 6 resources, 2 go to the drain, 4 come to the pool. Step 2, same again, so we've got 8. Step 3, we're then at 12. So well done, everybody. I think the vast majority of people got that one right. A couple of people didn't, but don't worry, it just takes practice. Cesar, how are you going to use your gates in your models?
Yeah, gates are very versatile. No? There's a bunch of ways to use them. The main way you're going to use them, though, is for distribution. So imagine that you have, well, even though they are frowned upon, imagine you have a loot box, right? Imagine you have a scenario where there's random chances, like the chance to drop a skin or something, and you know what the odds are for that. You are going to use a random gate to simulate opening that type of loot box, for instance. You can use it to, if you want, for instance, to create, let's say, health for 2 different players. Let's say you have a team game and there's a type of healing that gives health to both of them. You can use a gate to split those resources between the 2 players, right? Whenever you want to either split or randomly decide the output of a different resource, you can and will probably use a gate for that. There's also the triggering aspect, which can be really important as well. I think we should maybe discuss that in more detail when we reach triggers. But yeah, using gates again to simulate random chances of actions happening in your model is going to be done via trigger gates.
Perfect. There's a great question, actually. They thought it was a dumb question, but could you use this to simulate product funnels, functions, user onboarding, incorporating historical bounce rates, etc.? Yes, absolutely. We build all of our marketing funnels, sales funnels, pretty much everything inside Machinations. It's a great way of kind of communicating on how those sorts of aspects work. So, you know, user acquisition and marketing funnels. What's the bounce rate? What's the number of impact that you can get into the top of the funnel? And how many new players will you get, as an example, is a great thing to do inside Machinations. Up next, we're going to talk about converters. And actually, before I get into converters, if anyone does have any questions, please do drop them into the Q&A or into the chat. We love it when if you've got a question, I'm sure somebody else does as well. So please do ask it as we go through. Up next, we're going to talk about converters. Converters, as the name suggests, they convert resources. So here, we'll look at my interactive one for a moment. Again, we do have those 4 different trigger states. Here's my interactive one. It's taking 5 resources and it's converting them into 15. Here I've got 5 going into 1. Again, just like gates, converters are intermediate objects. This means they carry out their action during the simulation. So here I've got 5 converters. They take the same amount of time as just a connection from a source to a pool. We can even get fancy and we can combine converters and gates into one giant flow, and you'll see this end pool is filling up at the same rate as this one. So we can create all sorts of logic and fun all inside one step using this sort of technique. Where we quite often see these being used is we have 2 additional options on our converters. One which is single. So when it's single, this means that it'll carry out its action just one time. So this is going to convert 5 resources into 1. But you'll notice we've got excess resources building up there. If I make that multiple, it's going to convert as many times as it can using that ratio of the number before the converter and the number after. So here we've got 15 resources coming in. So it's going to convert 15 into 3 each step. And here we've just built this up so that we've got a feedback loop on this. So for every 1 that we end up in our pool, we're increasing the amount of resources coming into this first pool, which is exponentially increasing it. Now, one of the key things with converters is by default, they actually all have that all characteristic that we've seen in pools, gates, and drains. So here, although we've got excess of one type of resource, I'll let it fire once. It's going to wait until both of its incoming requirements are fulfilled before it carries out its action. It's got plenty of this resource available and it only requires 2 of them, but it's waiting until there's 5 from this one before it carries out its action. Converters, although they can have as many inputs as you like, they can only ever have 1 output. So here I've tried to connect 2 outputs to go to 2 different boards to convert 5 into 8. But when I hit play, this is going to get grayed out and it's going to show me the error message of why it's saying that. If I did want to have a mechanic where I was maybe breaking something apart and I was going to take something from one number, but I wanted to distribute it into multiples, the way in which we could do this is by adding an extra gate in here that's deterministic. So here I'm going to take 5 objects, convert it into 8, and then distribute this 5 and 3 between these 2 options. Now, hopefully I haven't spoiled this one. But Cesar, what have you got for us next?
For you next, I have 2 answers to give to the Q&A section.
Okay.
The first one is, have you considered adding labels to symbols to make diagrams more easily presentable that might do to stakeholders that might not be familiar with Machinations? So Matthew, if you will show labels.
Oh yeah, I will, but I'm going to do it away from my puzzle so I don't spoil it.
Please do.
So here we've got the labels. So maybe I should make sure I include this in our intro next time. But here we can add the labels onto these so that we can show what they're doing. And then we can even add resources, labels onto our resource labels so that we can wiggle these around and make sure that it's clear what's going on. So we can really quickly start to build up and explain what everything that's going on with the different objects, and these could represent anything. So rather than it being just saying it's a pool, we know it's a pool, but let's say this is coins, this is breaking up object. That's a great question though. Play game. Does that make sense? Perfect. What was the next question, Cesar?
Next question. Okay, they're piling up so beginner question. This one is, I don't know if you can answer. So is this type of diagram the equivalent of a UML diagram in software development? How is randomization determined? Is it just by guessing?
So yes, I mean, this is a equivalent of a UML. How is randomization determined? So that's using Monte Carlo simulations. We are going to talk about more randomization in a little while, but effectively gates are one of the key ways that we do this. So if I were to make that random, it's then going to apply randomization to the outputs, or I can keep it deterministic so that it's not quite so random. Hopefully that answers your question.
Yeah, so for the exponential increaser, is there a way to apply that to the die systems? So basically multiplying a dice instead of throwing 1 dice with, you throw 10 dices, right? Yes, sure. My answer to that is you would need to create that separately. So there's 2 ways you can do dices. One is we'll cover that, you do the D formula in the resource connection, which we'll show later. The other one is if you do your maths inside the register. Now, to do that, to throw multiple dices, I think you're going to have to do your math inside the register. But yeah, that's totally possible. As long as you, instead of doing D6, you can do a function that selects a random number between 1 and 6 and have that be multiplied. You can, I mean, not multiplied, but like add more of them. Or if you want to do it on a formula, you can add multiple dices. But it's a tricky one to do, I would say. So
perfect. There's another question there, but we're going to circle back to it at the end if we've got time, because that is a much longer answer, I think.
And there's more coming, yeah.
Okay, let's jump into our converter question. Cesar, what have you created for us this time?
Yeah, again, we're looking at the last node that we explained. We have a fairly simple structure in here. We have our source, we have two pools, and the converter, which is going to attempt to draw resources from the source each step. You can notice that it is set to convert all, right? So it's going to try to convert all of the resources that it can in a single step. Question, yes.
Multiple.
Please, Matthew. And the question remains, how many resources will the final pool, so the rightmost pool, have after 3 steps? This one, I will give you a hint. It has a small trap in it, just a small one.
Think about your timing of your steps, I think there.
Yeah.
Okay.
Matthew's even giving hints. Okay.
I'll launch that poll. Have a think about it. Do that maths on your fingers. We've got 10 each step, then we're taking 5 and converting it into 1, 5-to-1 ratio into that end pool. So we'll give you a couple of seconds to answer that, and then I'll end the poll. This one it's a good one. This one. I do love the multiple conversions in one step. That was.
I see in chat, click the wrong answer. My mistake. I'm sure you did. I am sure you did.
Right, I'll end the poll there. Let's find out how we're doing. So step 1, we get our 10 resources. This is the part that could catch you out, because it's going to take 1 step to get our first resources into here. In our second step, we're going to convert those 10 into 2. And then in our third step, we're going to convert another 10 into 2. So that's going to give us 4 resources. I'll share the results. Again, I think most people got that one right. Well done if you did. Give yourself a pat on the back. Cesar, quickly, we're not completely running out of time, but
yeah, we are. Don't pretend. Converters, right? So you would use converters. I think I mentioned it in a previous example. So imagine converting a health potion into health, right? You would take 1 resource from your health potion pool, put it through a converter, and convert it into 50 resources of health. You can also think of it as item crafting, for instance. You take 3 materials, you put them through a converter, you spit out the final item. Or there's a bunch of different applications, but the idea is that you take resources from one place and convert it into resources of another type.
Perfect. Up next, we're going to talk about traders. Before we get into traders, just going to talk about one extra feature, which is the color of our resources. So Machinations has 5 different colors of resources. Here, I've configured this one to produce blue resources. They're firing them all into here. On the resource connections, I'm then using a filter to filter them by color to separate them out into their individual colors. And traders use these colors to simulate a trading action, as the name suggests. So we'll have a look at this on our interactive one. Here, we're going to build up 5 resources. Once I've got 5, I'm going to trade these 5 blue ones for 1 black one. If I try and do it before there's 5, it won't let me. But once there's 5 there, I can go through and do that. Just as we saw with converters, we've got the ability to do a single. We also have the ability to do multiple. So here I've built up a whole bunch of blue resources. I'm going to activate this, and it's going to convert all 50 into 10 black ones within 1 step. Now, Cesar, what are you going to use traders for?
Yeah, traders are, well, as the name implies, used for trading, especially when you have limited inventories. So this is probably my go-to use for traders. Is think of Skyrim, for instance. For those of you that have played it, in there you have merchants that have a limited number of items to sell and a limited currency. So they don't have, like, you cannot forever sell. They have like 700 gold and then they run out of gold, right? You would use your player inventory and your player currency and the trader's inventory and the trader's currency and swap between the two using a trader. You can also use 2 converters if you like being adventurous. Trader is probably the simpler way to do it, though.
Okay, perfect. Up next, we're going to talk about delay nodes. So delay nodes, as the name suggests, they delay resources. So we'll have a look at our interactive one here first. When we trigger this, it's going to pull 1 resource from the pool. It's then going to wait the number of steps that are on the outbound connection, and then it's going to release that resource. So one more time, we're going to pull that resource in, and it's going to release it 3 steps later out into the next object. Now, if we watch the automatic one, you'll see it's pulling in 1 resource each step. Each resource is then delayed by 3 steps, and then they're all output into the end. This means to get 10 resources from the left pool into the right pool, it's going to take 13 steps. There they come. The other option that we have on our delay nodes is, rather than delaying them, we have a queue system. So this, if we watch our automatic one, it's going to pull these resources in each step. So it's going to take 10 steps to get them all in. Then it's going to release one resource every 3 steps. So they're gradually coming out. So to get those 10 resources through this queue node, it's going to take 30 steps. Now, Cesar, what are you using your delay nodes for in your models?
Yeah, so delays in queues. Delays, the first thing that would come to mind is cooldowns, right? You have a skill, you use it, you send the resource into a delay, it stays there for a number of steps, then returns, the skill is again available for use. What I would use queues for is when you have a system where, let's say, take a game where you train soldiers and you have a barrack and you train those soldiers one by one, right? So it takes 10 minutes to train a soldier. Then after 10 minutes, the next one comes out after 10 minutes and so on and so forth. You would use a queue for that, right? Because it's not like after 10 minutes, all of the soldiers come out. So this is the difference between delays and queues.
Perfect. Now I've switched over to our other model, which is, we've been through all of our objects. Now we're going to talk about our connections. And we've been looking at these connections throughout today's session. Let me slow this down slightly, but I'm going to just go through in a little bit more detail how resource connections work. So the first thing up is we've got 3 different options in our functions panel here. The first one is the label. So this is where we can apply a label to our model, so to explain what this resource connection could be representing in our game. The number that we then have in our formula, this is how many resources can go along here in one step. So here I've got 1, it's sending it across. Here I have 5, so it's sending 5 resources across each step. And here, where it's blank and it's empty, whenever it's blank, that just means 1 resource. The other lots of options we have with this, but the first one is all. So when I put all in there, this will send all resources across, no matter how many there are. We had a nice long debate recently in our Discord channel of whether all is more powerful or not than infinity. I don't know where we came to in the end with that, Cesar, but if you have infinity resources, will all remove them, or would there still be infinity if you pulled all of them somewhere else?
It's still up to debate, but at the moment it pulls all of them. So
it pulls all of them. Perfect. So the next option we have here, we're using a D5, and what D5 represents is a 5-sided dice. So D5 will then produce a number of resources ranging from 1 to 5. So it's going to be random, so that it's using that Monte Carlo system again to randomize how many are coming across. Up next, we have 3 times D5. Just a word of caution, this doesn't represent 3 5-sided dice. This represents a 1 5-sided dice multiplied by 3. If we wanted to do 3 5-sided dice, we could do D5 plus D5 plus D5. You'll notice I've got capital and lowercase, both work the same. We can also combine a static flow rate, so 6 plus D5, to give us a number between 7 and 11. I think this is answering one of the questions we had a little while ago, which was around the time it takes, or the intervals between resources moving across. The third box we have here in our panel is the interval. So here, where we've got it set for an interval of 2, this means that 1 resource will move across this every 2 steps. Here we've got it so it's 5 every 3 steps. Here we've got it 5 every D5 steps. So that's going to randomize it each time, and it's going to send 5 resources across every 5 steps. We can also use percentages here. So here I've got a 50% chance of 1 resource going across. Here I've got 2 times 25. We can even start to get quite creative. So I've got 1 plus D5 times 10% every D6 steps. So we can create some quite complex logic around how many resources are flowing. We can also use some maths.js functions inside here. So here I'm creating a random integer, random int, between 0 and 5, which will produce a number between 0 and 4. So it's always one less than the top number. That's how many resources will go across this connection. Here I've got a sum of 1, 5, and 2. I'm not sure why you wouldn't just write 8, but it can be done. Just a word of caution here that you can't use state connections into these as a value. So we're going to have a look at registers in a moment where we're using letters on our state connections. We can't do these into resource connections. They're not a full replacement for a register. So Cesar, do you want to talk about resource connections?
I mean, yeah, we've been showing them all evening, right from the get-go. Whenever you want to transfer resources from one place to another, so those are the connections that support resources. We only have 2 types of connections, so it's not that complex as nodes are. But yeah, resource connections are the ones that are used to transport resources between nodes. State connections are the ones that you will learn right now what they are for.
Perfect. So state connections, there are a lot of different ways of using state connections. And the key thing you want to think about with a state connection is a resource connection is moving resources, hence the name resources, whereas a state connection is moving state information, so it's moving information, not resources. So the first use of a state connection I'm going to talk about is a node modifier. And what this means is that whenever we put one resource into this pool, we're using a node modifier to add another resource into this pool. We can get quite creative with this. So here I've got 1 plus 5, so it's adding 5 resources to this right-hand pool for every resource in this left-hand pool. Here I'm going the other way, so I'm removing 1 resource from this pool for every resource in here. I can stack these together, so I've got plus 5 and then plus 2. Here I'm doing plus 5 and then plus 2, but this is really important to know about with node connections. I know it's easy to get caught out with this, which is node connection information moves in one direction only. So if I were to remove resources from here, it would also remove the resources from these other pools. So you've got to be careful how you configure these. One of the great uses I use node connections for all the time, here I've got resources coming into this pool, and say this was my gold coins. I'm going to call that total, and then I'm going to call this current gold coins. So this means that if I want to track how many gold coins players received in total, and then I want another pool to show how many gold coins they have at the moment, this is a great configuration to do that with. Do need to be careful if you then start draining them from the source and the target of this node connection. You can see this one's got out of shape. It's now trying to say -5. That's because we're putting 5 resources into here. We're draining them, and then we're putting them back, but we're draining them from here and here. So eventually we end up with a bit of a broken construction. Also, these node connections work on the very first step. So here I've got 10 resources. When I hit play, it's going to pop those 10 resources straight into there. And this one's going to carry on counting up from there. Node modifiers and node connections only work between pools. So if I try and do +1 from here into a gate, it's just going to get grayed out. It's not going to work for me. Same if I try and do it to a converter. Next, let's talk about label modifiers. So with label modifiers, they're modifying the labels. We're super creative with names here. So here I've got a resource connection of 1. We're adding 1 resource into this every other step. So for every 1 resource in this pool, we're adding 1 to this resource connection. So therefore it's increasing the flow rate between them. We can get creative here. So here we've got a +5. we've got a -1, which will gradually slow this down. Here, we're doing +1, which I think I've already done, but we'll do it again. We can also, as well as adding resources to this resource connection, we can also add interval. So here, rather than adding, we're using the label of +1i. So this means that for every resource in this pool, we're adding one interval to this connection. So it's going to go from 1, so now it's going to send one every other step. Now it's going to send one every 3 steps and so on. We can slow this down with -1i. We can even combine both of these with multiple connections. So here we're increasing the flow rate, but we're also increasing the interval. And we can do all sorts of combinations of these to create the type of logic that we need. Using the same principles, we can also add percentages. So here, for each resource that's coming into this pool, we're adding 1% into this after this gate. Here, we're adding 5%. Here, we're minusing 1%. And here, we're adding 1% again. If we don't want to use this kind of +1 mechanic, we also have overwrite. And this is using the equal symbol on here. So before I start this, this is set for 200. But the moment I hit play, that overwrite is kicking in and reducing that to 0, because that's how many resources there are in here. Once we have 6 in there, it's then going to put 6 on this resource connection. These also work as node connections. So here we're using a node connection with an override. This means that no matter how many resources are in here, this pool is going to get overridden with this number of resources. So even though I keep trying to pull them out, it keeps resetting after each step so that these are the same. A couple more uses of state connections. The first one is to set up conditions. So here we're using greater than 0. So this is only available once this pool has more than 0 resources in it. So now there's 1 there, it's going to allow resources to flow. Here I'm using less than 5. So while it's less than 5, it's available, but once we receive 5 resources, this is then going to turn this one off. Here we've got equal to 2. So while it's 0 and 1, no resources can flow, but once it's 2, it will allow resources to flow. Hits 3 again, it's no longer available. We can do greater or equals, smaller than equals, or even ranges using 3.5. So this will only enable resources when the number of resources in the pool here are between 3 and 5. We can also use exactly the same logic. Rather than pointing at a resource connection, we can point at objects. So here I've got greater than 0. Once this pool, has got more than 0 resources, it will enable this. And it's the same logic as just as we've seen before. This time though, just wanted to be clear, if we have passive objects that are being enabled, they're still not going to fire. So here I've got a passive source and a passive pool. Even though this is then enabled, there's nothing to actually trigger these. So in this bottom one here, I've then set this up so that we have a automatic pool. So once we hit more than 5 resources in here, the pool will then trigger the source because it's then available. We can use these types of conditions on any other object. So here we've got a source, we've got some converters and a gate all being used on these. And we can even then use state connections to apply to other state connections. So here I've got a configuration that's saying, okay, this is only available when it's less than 3. But once we then start to send resources here, the resources are increasing that value. So now it's only available when it's less than 5, but we're at 6 already. Couple more usage of triggers. I think we've got 2 more to go of state connection. Sorry. So the next one up is triggers. The way triggers work is these will trigger our passive objects. So here, every 3 steps, I'm going to receive a resource into here. This is then going to trigger the source that's going to move one resource down. So these are both passive. This is then triggering that action so it will carry out its task. And we can apply this to all sorts of things. Again, we do have to be careful with our automatic states. Here, we've got a pool that's going to trigger this source, but because this source is automatic, it's going to be firing its action anyway, and that trigger is not going to have any impact on it. With triggers, we can trigger any type of other object. So here I'm triggering a source, a gate, and a converter. Here I'm then combining these actions. So once it's greater than 0, this pool will then be available. And then the next resource that comes in here will trigger it. So you'll see the trigger did nothing that first time. Once we're also greater than 1. This pool is then available and it will start to receive resources. It's set with a push action. So the next resource that comes in will fire the trigger and push these into the next pool. We also have a reverse trigger, very rarely used, I think, Cesar, but we use these. Here's a great example of a way to use them. A reverse trigger will trigger another object when the source object cannot complete its action. So this is an automatic converter. There aren't 20 resources available for it, so it's failing to carry out its action. Once we get 20 resources in here, the converter can then fire. This is then converting the trigger. So this is a great way of counting how many steps it's been since the converter's been able to carry out its action. Up next, let's talk about end conditions. So end conditions are ways of stopping the simulation. While I'm playing the simulation here, our step counter's gradually ticking up. If I fire one resource into this pool now has greater than 0 resources. Therefore, it then triggers the end condition, which stops the simulation. And we can do any combination using these conditions with end conditions to stop our simulations at certain points. Very relevant when we get into batch plays. Up next, we're going to talk about registers. Actually, Cesar, do you want to talk about state connections?
Yeah, well, you see that state connections have a lot of use cases. They're going to be used to model a lot of the logic that you have in your model. Personally, when I go and build a more complex model, it's a horrible mess of different state connections all over the place. So if you're going to have any type of logic in there, you will use state connections to simulate that logic. And we also have a question that I totally forgot about. Yeah. So Matthew, the exercise here is the same as before. We have our pool that interests us. We have 3 steps that we're going to run. You can see that we have a trigger in there. You can see that we have a label modifier, right? That's going to change the number on the resource connection. We have a converter in there. So also note that the source is set to on enabling, so it will only trigger in the first step, right? But we also have a trigger. So this is a bit of a more complex question here. There's a lot of things going on, but the question remains the same. How many resources in the pool after 3 steps?
Perfect. And I'll launch that poll. This is our final question for you, stat fans. How many resources are we going to get through this in the 3 steps? There is a trick here with the on enable and the trigger. We'll give a few more seconds. I know we're well over time, Cesar. I'm doing really badly today.
You are doing great in the last 10 minutes.
We're almost at the end. Don't worry, folks. We'll be done in.
And then we'll open up Q&A. So
perfect. Right. I'll end the poll there, and I'll do the first step. The first step is converting 1 into 1. This has then added a +1 onto here. You'll notice that this connection's then gone blue between them to show that the trigger's about to fire. We'll do one more step. That's converted 1 into 2. So we now have 3 here. It's adding 3 onto here. Our trigger's ready to be fired again. One more step. for our third one, and we've then got 7 resources in here. So I'll show the results. Well done. This did have a big catch in it with that on enable trigger characteristic on the source, but the trigger, so that once the resource hits the end here, it would then trigger the source again. So if you got caught out by that, don't worry, you're in good company. That's a tricky one to understand. Right, let's talk about registers. So registers, these are one of the most powerful objects inside Machinations. We use them all over. There is a dedicated session we did a little while ago just on registers. We spent a whole hour looking at everything that they can do. But for now, let's just talk about a few ways of using them. So using state connections, we can create different types of values. So here I'm using the letter A, here I'm using the word letter, and here I'm using the word. So A plus letter plus word, this is counting up how many resources are in these pools. So you'll see this gradually ticking up by 3. The other option that we have of registers is to set them as interactive. So here I've got 20 resources. I'm using a state connection with +1 to adjust this flow rate. I can then tick this up and down as I want to while the simulation is playing to adjust the number of resources going over this connection. Now, really importantly, this has an initial value of 20. So while the simulation is playing, if I ramp that up to 280, when I hit stop, it's going to drop that back down to 20. So now it's 20 again, rather than that 280. If I want to adjust it and keep it that way, I've got to set my initial value here so that when I hit play, it's got that 280 there if I want it. Using these, we can create all sorts of different types of logic. So here I'm using a register. I've got a couple of random number generators for me here. This one, I've configured this as a OR gate effectively. So here it's saying if this pool or this pool are larger than 2, that means it's whenever we have a condition inside a register, if that condition is fulfilled, it's going to give it the number 1. If it's not, if it's failing in that condition, it's going to be 0. So this, if both numbers are over that, it's just going to be 2. If just one of them is, it's going to be 1. If neither of them are, it's going to produce a 0. If the register is then greater than 0, producing 1 resource that goes into our register, into our all register output, if you like, into this pool. Here, rather than using a plus between these two, I'm using a multiplication. So both of these have to be larger than 2, because anything multiplied by 0 is 0. Therefore, both numbers have to be higher than 2 for this to be greater than 0 and trigger our source. Cesar, what are you using your registers for?
Yeah, first of all, I want to say to those watching, please don't stress too much about what we're showing here with registers, right? Think of them as the nodes in which you do your math in. They have a ton of applicabilities. Horia has linked the 102 session in the chat, so there is that's a session where we go in talk about registers and show the different functions they can use. But I am personally, the register for me is my favorite node. I use it a lot. It creates a lot of logic. It looks at certain, so imagine, just give one single use case since we've been talking about health all evening. So imagine that you have a player and you want to impose a rule for that player that whenever they are below 50% health, drink a potion so you avoid getting one shot. You would implement that by using a register, right? You would send the pool information into a register, check if it's below 50%, and then trigger a condition for the player to use a potion and convert it into health. So this is a simple logic. A lot more complex logic can be made using registers, but you would use registers for that. So they are very, very powerful and useful node.
Perfect. Now that we've kind of been through all of the objects and we can make sure we've covered all of these off as we go down, this is a model. I think, did you make this one, Cesar, or does this one go back even further? This
No,
is
no, I made it, but it's an older one. It's a legacy one. Let's
the legacy one. This is Super Mario Brothers, and what I wanted to just do with this is just explain how our chart works. So we can go to any of the objects, pools and registers, and we can select this show in chart. What this will do is we'll add them into our chart. That means that when we're playing our simulation, any values that we're then able to collect are then shown in our chart. In here, as well as there's a couple of options, we can make them visible, we can make them highlighted. If we want to make them bar chart, we can do, or if you want to make them lines or area charts. We've got two scales. So if you have two numbers with very, very different results, so our coins are now kind of much, much higher. So we're looking at these on one axis versus the other. So we can really quickly build up the data and start to visualize what the results of our mechanics are that we're creating. As I hover my mouse over it, I can see the values at that point. If I stop my simulation for a moment, I can zoom in and focus just on one particular area of the chart. Then if I really want to start building up the data to see what's going on, we've been using play and we've been using step throughout today's session. But the other option we have here is batch play. Now, what batch playing will do, it'll take the model, it'll send this up to the cloud, and it'll run, depending on which plan you're on, it'll then run multiple parallel streams of the simulation. This enables us to run huge amounts of simulations very, very quickly. So in that couple of seconds, I just ran 20 simulations, as well as having being able to see each individual result. I've then added a number of indicators onto our coin points metric. So here I'm looking at the average, which is this bold line down the middle, and also our minimum maximum values, so I can see how wide the spread is of the simulations. Obviously, when we come to talking about statistical relevance, some simulations, a couple of animated plays or interactive plays are sufficient. When you then really want to build up data, you want to start running lots of simulations. And we often talk about this wiggly line and our average line here. We want to run enough simulations to the point that that's no longer varying with each simulation. Cesar, anything you'd add on that I've missed to talk about the graph or the chart here?
I wouldn't say no. I like the part that you mentioned statistical relevance and looking at the average. Yeah, for some types of systems, this number can be as low as 10. For some types of systems, it can be as high as 1,000,000, right? So it really depends. But you have the tools to do quick simulations. So it should, in the end, provide statistical relevance.
Fantastic. Well, thank you very much, everyone. So that's all of the kind of the planned content we had for today. Now's the perfect time. I think, I know we're 15 minutes over. I've completely failed today talking for too long. But if you have any questions, we'd love for you to just drop them into the chat and we'll try and ask them.
Yeah, but we'll start with the Q&A first, I guess.
Perfect. So I think there's a couple of them here. Is there a systematic way to add player dynamics? Player may or may not be able to find the health token within the game. How do we apply that dynamicity in Machinations? Cesar, do you want me to answer?
I can take it, but I want to touch upon one important aspect, which is it really depends on how you want to model your game and how you choose to abstract your game, right? Because if you say, is the player able or not to find a health token, then we are going into what is your player doing inside the game, what is your player doing in a single step, right? We modeled a type of RPG-like game a while ago in one of our webinars, and the way we had our player behave in our simulation was that one step was one action that the player took, right? They could roam the open world, they could search for items, they could fight mob or something like that. In your case, I guess the equivalent of that would be your player roaming the world or searching for a potion or searching for a health token, and it would be using a random gate for a probability to either successfully found token or fail to find token and going back to roaming. So yeah, you would probably use a random gate for that, but it depends on how you structure your model and what your player does in a single step. It's very important. Do we leave the big question for last? That's my question, Matthew.
That's what I was thinking, because that's a really big question.
Okay. I was prepared to answer it. It's fine, but it's yeah, it's fine. We'll leave it for last. What about plugins? Is there a way of getting closer to code generation from these designs? I'll leave that one up to you, Matthew.
Oh, I'm going to talk about the Unity plugin. Okay, so we do have a plugin with Unity, and the way in which that Unity plugin works is that you can connect any object or state connection or resource connection from Machinations directly to any scriptable object inside Unity. This means that if you're going through that iteration design process and you're looking to find your game balance, one of the kind of the painful points, especially when you're going through that in the development process, is if you make a change or a tweak to one of the values inside the game engine, it can take a very, very long time to understand what impact that's having on the entire player journey. So the advantage of that Unity plugin is that you can then run a simulation from inside Machinations. So if you tweak a value inside the engine, you can then come back to Machinations. It will automatically update those variables. You can run 1,000 batch plays and go, well, what impact did this just have across my entire player journey? So rather than having to make a change in the engine and then send it off to Q&A for 2-3 days worth of play testing to understand the impact on the game balance, you can do that inside Machinations much, much faster. There is a bit of overhead in terms of managing. You've then got to manage the synchronization between the two, but depending on your workflows, it can be a very, very efficient way of doing things.
Next one. I want to use Machinations to build multiple complex models of a MMORPG's economy leveraging blockchain technology. Do the free codes available on your website also have the purpose of helping and answering specific questions about the models people are building? I think that one's still for you, Matt.
That's a big question. So really pleased to hear you're looking to use Machinations to build that type of economy. Web3, MMO, RPG economies, that's going to be super complex. So with our free plan, you can start to build out models like that. In fact, we've done a couple of sessions recently where we're looking at how to build sustainable Web3 economies. We also did a session with the Heroes of Mavia team a couple of weeks ago that's just been posted onto our YouTube channel. And I'm sure Horia will instantly drop a link to in our chat for you. And it's a great way of kind of understanding the process you need to go through to build out and prep for that sort of plan. We may have some interesting services you might want to come and chat to us about if you're building that sort of system. If Cesar could drop the link to my meeting booking system into the chat, we'd love to have a chat with you, Igor, and talk to you a bit about it a bit more. But we can't really talk about it too much at the moment because it's not fully announced. So look out for that in a future session with Machinations.
And do we tackle the big one now?
Yeah, let's do it.
So this might be a long answer. Okay. If you can point out a model I can study, please let me know. I have the following scenario. 10,000 users have 10,000 cards. The cards are of 10 types. Is there any way to simulate what type of cards will each user receive? And if users can trade cards after X steps, what cards each user holds, and how many manage to convert 7 cards of the same type into a prize? Now, there are some information missing in this question. So if you say 10,000 users have 10,000 cards, does that mean that each user has a card? Are the cards distributed randomly between the 10,000 users? Is each user given an equal amount of cards? So information like that. But the first question would be if you're working with 10,000 users, 10,000 different users, and you would like to see how many cards each of these 10,000 users holds, you would from the get-go need 10,000 pools to store those cards in. So either you take an approach where you look at different possible combinations that the user might have instead of looking at 10,000, since you only have 10 types of cards anyway. There's only so many combinations of cards that the player can have. So going up to 10,000 may be a bit overkill if you don't feel like placing 10,000 pools inside the model, which I'm not sure even would run. But it's definitely, I would have an in-depth look at that question, but would need more information to properly answer it. My first thought on that is that it could be done as a complex model, but you would need to abstract some of that a bit more. So instead of looking at 10,000 users, maybe look at 100 different users or take it even further. But again, it depends on how many cards you give each player. It depends on what's your distribution method. It depends on how they are trading. So all of these are important when building a model. As for, do we have a template for that? I am not sure. I will say that building, in general, building trading card games in Machinations proves to be more difficult than other games because there's a lot of cards involved and each of them have unique properties, and you would have to look at those unique properties. I myself have recently built a trading card game. I have built the logic for playing. There aren't a lot of cards in that game, and I've made a simple logic, just play a random card, and it still took like 2,500 nodes, and it got pretty gigantic. So I wouldn't say it's impossible. I would just say that trading card games are definitely hard ones to model if you're looking at individual cards. If you are not looking at individual cards, then again, it's a question of how much do you want to abstract your model.
Perfect. Great answer, Cesar. That was an in-depth. There's a lot to kind of unpack there. There's a huge amount that you can do with Machinations. I think one of the biggest challenges I think everybody faces especially when you're thinking about a system like that, is how much should you abstract and how much should you go into kind of full detail. It's easy to get drawn into, all right, let's build 10,000 pools for 10,000 players and 10,000 pools for 10,000 cards and everything else. And actually, you can abstract a huge amount of it away. How many different types of cards there are, that's really where you need to focus. So we often spend a lot of time talking about the strategy of, you know, how much to abstract or not, and also how much do we want to, what does a one step mean in a model. We'll spend a huge amount of time just thinking about, is one step a turn in the game, is one step a whole game, is one step a day, a month, a year. We'll look at all the different permutations around that. If you are looking for extra help or extra inspiration on getting some ideas on how to build your models, I would definitely recommend checking out our community pages, where there are a huge amount of users and game designers around the world that are sharing their game design ideas across the community. Everything from previous contents we've done, so I can see where someone's just forked my diagram to play around with it, and different types of content that they've created, from some extremely large complex models to the more simple abstract models of games like Pac-Man and all sorts of things. As well as seeing models, you can then come along and follow some of our designers of the month, so you can see what Franz has been working on, what sort of models he's been creating for his content. So he's obviously working on the final exam gacha systems. Get inspired and get some ideas of how they can do things. So thank you very much, everybody, for coming and joining us today and going through our Machinations 101 session. Really looking forward to see what you guys come up with and the models you build to test your game economies. Now that you've learned all of the basics you need, please do give us a shout and show us what you've built in the community. Enjoy the rest of your day. Thanks.